Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haiman Sakawi bin Halus Giman from group RAS1203D. We'll be doing a video presentation on PHY150 on the topic of magnetic separation technology in recycling industry. This is our group member. There is me again, Muhammad Haiman Sakawi bin Halus Giman as the group leader, Muhammad Syami Hazim bin Suhaimi and Nabil Iqbal bin Rosli. This is the table of content. There are 8 content that will be explained in this presentation. The first one is introduction. Second, explanation of relevant electricity and magnetism concept. Third, detailed exploration of the chosen technology. Fourth, example of real-world implementation. Fifth, potential benefit and challenge. And sixth, future development and innovation. 7 is the conclusion, and the last one, 8, is the reference.
Hi, my name is Muhammad Syami Hazim bin Suhaimi. So for the introduction, magnetism is the fundamental force of nature arising out of movement of electric charge. It is essential in several industries from power generation to transportation and now increasingly used in recycling processes. Magnetic field created by magnet or electric current exert force on magnetic material, usually ferrous metal, and can be manipulated for various purposes. In recycling, magnetism separated and recover valuable metals, adding to the efficiency and sustainability of recycling operation. This method are been used since 1960, where at that time permanent magnet are being used. But nowadays, we are not using the permanent magnet. Instead, we are using electromagnet. So, as you can see, this is a difference between permanent magnet and electromagnet. For the permanent magnet, it was permanently magnetized, made of hard magnetic materials. Magnetism doesn't vary in strength, and we cannot alter their poles. While electromagnet are temporarily magnetized, made of soft magnetic materials. Magnetism can be vary in strength according to needs, and also we can alter their magnetic poles. This is show that electromagnets are most suitable for use because they are magnetic, which temporarily facilitated the process of collecting material containing iron element for recycling.
My name is Nabil Iqbal bin Rosli. Next, I will be talking about the relevant electricity and magnetism concept. First is the electromagnet. Electromagnets are made of coil of wire with electricity passing through them. Moving charge creates magnetic field, so when the coil of wire in an electromagnetic have an electric current passing through them, the coil behave like a magnet. When the electricity stop flowing, the coil don't act like a magnet anymore. So this is the example of electromagnet. Next is the attraction of ferrous metal. Ferrous metal is a type of metal that contain iron such as steel, nickel, and zinc. When an electromagnet is being energized, it generates a powerful magnetic field that attracts ferrous metal. This magnetic force enables the electromagnet to lift and retain ferrous metal. This is the example of the ferrous metal. And lastly is the selective metal sorting. Metal recycling facilities often utilize electromagnets in conveyor system or crane. As materials travel along the conveyor, the electromagnet can be selectively activated or deactivated. This enables the separation of ferrous metal from non-ferrous metal. When the electromagnetic is off, non-ferrous metal continue moving along the conveyor while the metal are attracted and collected. This is the magnetic crane. Next is a detailed exploration of electromagnet used in recycling facility. First, in a magnetic crane, there is magnetic grapple. These are the specialized attachment to the crane equipped with powerful electromagnet, enabling the lifting and handling of ferrous metal. And next is the lifting and moving the scrap metal. This is the initial step with the crane. It was equipped with magnetic grapple, will lift and move the scrap metal from the collection area. When the energy is being turned on, the magnetic force generated by the internal coil is then passed through the magnetic conductive panel to hold the scrap. When the energy is off, the magnet will demagnetize the magnetic force to remove the scrap. and then it will go through a cleaning operation. When the scrap metal is collected, it undergoes cleaning to remove any contamination like dirt, oil, or any other unwanted materials. And lastly, the materials separation and sorting. After cleaning, the scrap metal is sorted and separated on its types such as steel, aluminium, or copper, and even their grade is being separated. And then it will be go through shredding and processing. Finally, the separate metal is shredded into smaller pieces and then processed further, such as being compact into balls or melted down for recycling.
So this is the implementation. For magnetism in recycling, we use two types of magnet. The first one is overband magnet, a suspension magnet with a tram belt that is attached to a motor, adjoined to motor revolving the belt. It's majorly used when an automated removal of ferrous contamination is necessary. The next one is drum magnet. Drum magnetic separator consists of rotating drum containing a magnetic element, typically a rare earth magnet. The rotating drum continuously moves through the material stream, attracting and separating ferrous material from the non-ferrous material.
On to potential benefits and challenges. Although the usage of magnet in metal recycling shows many benefits for not only to the recycling process, workplace efficiency, and environmental sustainability, this technology also has some drawbacks that we like to address. For the benefit of using magnet in recycling, there are 4 that we have listed. First is that magnets are able to improve the efficiency of the recycling process. The usage of magnet not only allows the separating of the metal easier, it also faster compared to the traditional method of separating the metal by hand and less time consuming, which will increase the productivity. Secondly, using this technology can lower the operating cost, as magnet is able to be separated by large quantity of waste quickly and efficiently compared to separating it by hand. It means that the recycling plant do not need many workers to separate it, thus cutting on the operating cost. Third, it can promote safer working environment. Since workers do not have to separate it by hand, a safer working environment can be achieved as risk of accident from either falling in the waste or scratching themselves against the pointy part of the waste can be avoided. Lastly, applying magnet for recycling can improve the environment, as magnet is able to separate ferrous metal from non-ferrous metal efficiently. It can lessen the amount of waste that is sent to the landfill, which will in turn lessen the damage of the landfill toward the environment. Moving on to the challenges, there are 4 that we have listed. Firstly, the usage of magnet have a high initial cost. This means that a recycling plant must spend a lot of money to purchase a single magnet to be used in recycling, which, if done poorly, could bankrupt the plant. Therefore, it's no surprise why some plants decided to separate the metal waste by hand. Secondly, the usage of magnet will result in high energy usage. Magnets need a lot of energy to operate. Therefore, recycling plant operator must not only spend a lot of money in buying the magnet in the first place, but must also spend a lot of money on electrical bill to ensure the magnet can continually be used. Third, magnet can only be used to separate ferrous metal. This means that metals such as aluminium and copper, which are not ferrous, need to be separated by hand to be recycled and not be sent to the landfill as waste. Lastly, if in the event of the magnet not receiving adequate maintenance, it can cause contamination. What I mean by this as failure in maintenance will result in magnet not be able to work in its full potential. Therefore, the odds for ferrous metal to not be separated by the magnet increases due to its pole strength, which in turn will result in more waste to be sent to the landfill, thus increasing the contamination toward the environment. Moving to future development and innovation, there are several ongoing projects and development relating to magnet usage in recycling. The first development is the smart recycling system, in which the recycling process is further streamlined with the usage of robot and AI technology. This improvement can allow more efficient separation as AI sensors can be used to separate waste more efficiently, and the usage of robots can cut down on need of workers to operate the recycling process. The second development is the enhanced magnetic separation techniques, in which a higher magnet strength and more effective electromagnet design is being developed and used to allow more efficient separation of ferrous metal. This improvement allows for more metal to be efficiently sorted, which in turn will result in less waste. Lastly, the electronic waste recycling is being used with magnet. Electronic waste or e-waste contain valuable and useful magnet components that can be recycled. With the application of magnet, this component can be more easily separated for further recycling process, thus improving the environment and decreasing the overall waste on the landfill. In conclusion, magnet technology in metal recycling allow the recycling process to occur more efficiently and environmental friendly. Further development in this area will produce more efficient method and technology that improve the recycling process for the better.